Hello, grade 10 students, and welcome back. Today, we will cover lesson 5.3 Forces in Two Dimensions, part 4. We will also work through the corresponding applications and homework questions. So let's get started. The net force in matrix notation. Recall that the F net is given by F1 plus F2 plus F3. We can find the net force again for of two or more forces given in matrix notation by adding them up. We know that the F net can be re-expressed in matrix notation, and the matrix notation for any vector is given by the f of x and f of y. Another possible way to write this expression is by using the f of h notation and f of v notation. So the f of h and f of x, or the f of v and f of y. You can use this way or that way, depends on the situation. Now, the matrix notation of this formula can be written as the f net h, f net v, f1h, f1v, f2h, f2v, f3h, f2, f3v. As we can see here, the first row represent all the horizontal components or the x components for the vectors, and the second row represent all the vertical components for each of these vectors. If we add all the elements in the first row, such like this element, after the equal, we will get the f net h. And if we added all the elements in the second row, so the vertical components together, we will get the f net v. And after we found the f net h and f net v, we will need to find the magnitude of this f net. So we need to combine the horizontal component to the vertical component, and this can be done using the Pythagorean sum. Now, to find the direction, we need to find the angle with respect to the x-axis, and this can be done by using theta is equal tangent inverse f net vertical over f net horizontal. So let me clarify this idea by using this example. Determine the net force acting on an object in each of the following cases. Let me recall that whenever they want me to determine the net force, we know that the net force is a vector quantity. It has a direction and magnitude. So I need to determine the direction and the magnitude. Now, as we can see here, the given are the matrix notation of F1, the matrix notation of F2. The first entry here represents the f of x. The second entry here represents the f of y, as well as here we have f of x and f of y. Now, in order to find the f net, we just add f1 plus f2, and we will get the f net. Now, if I'm going to add f1 and f2 in matrix notation, I will expect to have the matrix notation of f net. And this is actually what happened here. After we add up the two forces together, we obtain the matrix notation of the f net. Remember, whenever you want to use the addition or subtraction in the matrix notation, you just add the entries in the first line together, the entries in the second line together. So 5 plus 3 is 8, 3 plus 3 is 6. Now the F net is equal 86 Newton. Now what will be the magnitude? Since that 8 and 6 can be drawn like this. This is the Fx, this is the Fv. They are perpendicular. So we have 90 degrees between them. The only way to combine the perpendicular forces, two perpendicular forces, is by using the Pythagorean sum. And this is how we use the Pythagorean sum. Square root f squared h plus f squared v. So let me correct this here. This is h. The direction here can be found using theta is equal tangent inverse minus 1, the fv over fh. So it will be equal to tangent inverse 6 over 8, and the answer is 36.8 degree. Determine the net force again. To find the net force, we need to find the magnitude and the direction. Now, in this case, we have again two forces. To find the F net, we just add them together and we will get the F net. Let me recall that if you add the matrix notation for F1 and F2, you will get the matrix notation for the Fnet. So let's do that together. 5, 3 plus minus 3 minus 6 is equal. Now remember here, we add the first row together, so 5 and minus 3 together, and the second row, the entries in the second row together, which means 5 and minus 3 is 2, 3 and minus 6 is minus 3. Now, let's start with the magnitude first, the magnitude of the Fnet. Remember that the Fnet now is equal to 2 minus 3 Newton. 2 represent the F of H, minus 3 represent the F of V. Now for the magnitude, we just apply the Pythagorean sum because we know that FH and FV are perpendicular to each other. So the Fnet is equal square root F squared H plus F squared V. 2 squared is equal 3.6 Newton. Now let me pay your attention to this idea here. The square will cancel out the minus, and the answer will be the square of the minus 3 is 9. So whenever I use the Pythagorean sum, it's not necessary to include the minus in the calculation. So if you forget to add the minus between the brackets, it won't affect the outcome, because even if you add the minus, the square will make it plus. So this can be applicable only for the Pythagorean sum whenever we have the square as well. However, for the direction, avoid to forget the minus. The minus will affect your result. So tangent inverse FV over FH. Now notice here, this is FV in the numerator, and FH in the denominator. So it's equal to tangent inverse minus 3, 2, and the answer is minus 56.3 degree. Now in part B, we need to find the net force, which means the direction and the magnitude again. So this is the net force, means the magnitude and the direction. And we have 3 forces this time. Remember that if we add F1 plus F2 plus F3, we will get the Fnets. And since they are presented in the matrix notation, the summation of them will be the Fnet in matrix notation. Minus 1, 4 is the first force, 6, 0 the second force, minus 2, minus 7 the third force. Remember that we are adding the entries of the first row together, the entries for the second row together. Now the Fnet that we will find is 3 minus 3. Remember, this is just the matrix notation of the Fnet. Now we need to find the magnitude. So let's find the magnitude. And this can be found using the Pythagorean sum. We simply add the squaring of FH and FV under square root, and the answer is 3 radical 2. You can re-express the 3 radical 2 in the decimal form, and this is equal to 24 Newton, 4.24 Newton. Let me remind you here that this minus, you can avoid to add it because it will be cancelled under the action of the square. So no need to worry about adding the minus. The direction is given by this formula. Theta is equal tangent inverse, the FV over FH equal to tangent inverse. Minus 3 is the vertical component, and 3 is the horizontal component. And here we have added the minus. It's important to add it. It will affect the direction. So the angle is minus 45 degrees. Again, we need to determine the Fnet. Here we have 3 forces. So we will add them together. Minus 3, 7, plus 1 minus 1, plus 2 minus 6. Now remember that we will add all the entries of the first row together, all the entries in the second row together. And the answer is 0, 0. And whenever the answer is 0, 0 for the F net, then the magnitude will be 0. This is application 2. Determine the net force acting on an object in each of the following cases. Let's start with the first case. Here in this case, we need to find the magnitude as well as the direction. Let's start with the magnitude. I need first to write each vector in the matrix notation. So let's start by decomposing F1. Now, the F1, it will be decomposed into F1x and F1y, as well as for F2, it will be decomposed into F2x and F2y. Now for F1x, first I need to determine the type of this angle. Now the type of this angle is with respect to the horizontal, so let me write here theta is with respect to the horizontal or with respect to the x-axis. And how we can know that? We just look at the angle between the force and the x-axis. Look at this angle, it's between the force and the x-axis. And since I said with the x-axis, this is the x type. On the x side, we apply the f cosine theta for the x component. And what about for the Fy? We will apply directly F1 sine theta. Now for F1 cosine theta, the F1 is given by 8, cosine the angle, and the angle is 39 degree. And here again, it's 8, but this time we're going to apply the sine 39 degree. So this is 6.21 Newton, and for this one, 5.03 Newton. Now, what about F2? Again, we have two components, F2x and F2y. Now, here we should pay attention to the direction because the direction of F2x is to the negative. So let me add here negative sign. Now, second, we need to determine the type of this angle. This angle is between the force and the y-axis. So this angle is theta y, which means it's measured with respect to the y. Let me write here theta y. So the f cosine should belong to the y component. And this is sine. Now the magnitude is 10. Sine, the angle is 27. And the answer is minus 4.53 Newton. And here we have 10 again, but this time we're going to apply the cosine. And the magnitude is 8.91 Newton. Now, as we can see here, we have the F2y and the F1y, the F1x and the F2x. Let's make the matrix notation for each of these factors. So for the F1, it's written as the two entries, 6.21. This is the horizontal component of the x component, and this is the y component. So always I start with the x, then the y. Now for F2, again, the x component and the y component. Now to find the F net, we just add these two forces together. So F1 is given by 6.21, 5.03 plus minus 4.53 and 8.91, which is equal to the F net. And the F net is given by adding the entries in the first row together, the entries in the second row together. To do that, let me show you how we can do that only for one time using the calculator. Now, what are the entries in the first row? 6.21 plus minus 4.53. So what did I do here is I just added the two entries of the first line together in my calculator. And the answer is 1.68. We will do the same thing. We just substitute them in the calculator or put them in the calculator. So 5.03 plus 8.98. or 91. And this time the answer is 13.94. Now we have the matrix notation of the FNet. We still need to find the magnitude and the direction. So let's start with the magnitude of the FNet. Remember that this represents the Fx and this is represent the Fy. And the answer for the magnitude is 14 Newton, approximately, or it must nearly to be 14 Newton. What about the direction? The direction can be found using theta equal tangent inverse Fy over Fx. So tangent inverse Fy is given by 13.94 and Fx is given by 1.68. And the answer for the theta is equal to 83.12 degrees. Now in application 2, we need to determine the net force again, which means I need to find the magnitude and the direction for the FNet. Before we do that, we need to find the component, each component of these forces, the force A, B, and C, and the given angles, 30 degrees here. For theta 2, we have 45 degrees, and for theta 3, we have 55 degrees. Now for FA is 20, for FB we have 60, and for FC we have 40 Newton. F of A. Now, what will be the type of angle here? The type of angle is the x type. So the F cosine should be applied for the x component. So let me write here that F of XA is written as the magnitude of the force multiplied by the cosine of 30. So let me write it directly. 20 cosine of 30. And the answer is 10 radical 3. Let me remind you that you can always re-express this value in the decimal form. Now for the XB, sorry, X, now it's Y. So YB, again, same values, but now we will use the sign. And the answer is 10 Newton. Now let's start with the FB. Again, we're going to decompose it into FXB and FYB. However, here, according to the direction of the B, it will be up and left. So the Fx of B will be left, the Fy of B will be up. So this is positive, this is negative. Or this is plus and this is minus, according to the directions. Now, what will be the type here of the angle? Again, this is theta x. So the F cosine should be applied for the x component. Now, the value of F is 60 multiplied by the cosine of the angle, and the cosine of the angle is 45 degrees. And the answer is minus 30 radical 2. What about the FYB? Since we have applied the cosine here, we're going to apply the sine there. However, the 45 degree is special angle because if we multiply the cosine or the sine with the same number, you will get the same answer again. Pay attention, this is minus, this is why we got the minus 30 radical 2. But since we have a plus here, the answer is plus 30 radical 2. However, you can always get back to the calculator to find the values for each component using 60 multiplied by cosine 45 as well as for the y component. Now, finally, this is FC. Again, it's measured with respect to what? The x, because it's measured between the force and the x-axis. So again, we're going to apply the cosine, the f times cosine for the x component. So fx of c and fy of c. Now the fx of c is equal to the magnitude times the cosine of the angle. So the magnitude of the force is 40 times cosine of the angle, which is 55. However, here I want to pay your attention to the directions. The direction for each component is given by this. So this is f of x of c. This is f of y of c. So both of them are negative. Moreover, you can say, since this is the third quadrant, everything will be negative in this quadrant. So let me make some space to add the minus sign. And here we have minus sine 40, sine 55. So the answer is minus 22.9 Newton and minus 32.7 Newton. Now we have everything to construct the matrix notation for FA, FB, FC. So FA is 10 radical 3 and 10 Newton. Remember that. This represents the X component. This represents the Y component. Okay, sorry, I found a small mistake here. So this is not B, this is A. Because here we have decomposed f of A. So fxa and fya. Yes, so for f of B, this is just minus 30 radical 2 and plus 30 radical 2 Newton. And finally, for f of C, we have minus 22.9 and minus 32.7 Newton. So in order to find the F net, we just add the three forces together. So let's start with the f of A, 10 radical 3, 10 plus minus 30 radical 2 plus 30 radical 2 plus minus 22.9 minus 32.7. Let's find the answer by using the calculator again. Remember that we're going to add the entries of the first row together and the entries from the second row together. So let's start 10 radical 3 plus minus 30 radical 2 plus minus 22.9. And the answer is minus 48. The same thing I should apply for the second row. So the entries in the second row are 10 plus 30 radical 2 plus minus 32.7. And the answer is 19.72. Now we have everything to find the magnitude and the direction because the F net is given by the two components, the X component and the Y component. Now let's start with the magnitude. And the magnitude is given by the Pythagorean sum since the fx and fy are perpendicular on each other. So the magnitude of f net is equal to the fx squared plus fy squared, which is equal to minus 48 squared plus 19.72 squared. So 51.89. Now for the direction, we apply the tangent inverse, the fy over fx. Now the value of fy is given by 19.72, and the value of fx is minus 48. So the answer is minus 22.33. Have f2x and f2y, and no need to decompose the f3 because already it's aligned along one of the axes. So let me draw here the f3. Now for the f1, since the angle given here is with respect to the x-axis, I can write directly that f1 is f1x and f1y. So the f1x is just the f cosine, so f1 cosine theta, and this is because the measured angles are with respect to the x-axis. And automatically I can say this is f sine theta. Now instead of writing the answers here, I would write them in the given sketch. And I will tell you why we can do that. Now here I'm going to include only the magnitudes without mentioning the direction, without adding the signs. So let me start with the F3. Now, in order to add the magnitude of F3, it's already there, it's 31. However, I cannot do the same thing for F1x and F1y because they are not given. And this F1 cannot be used here as F1x, not even as F1y. Because this is the value or the magnitude of the original force itself, not the components. We must calculate the F1x by using this relationship. So let me start with the F1x. The F1x, the value or the magnitude of F1x is, so F1 is given by 44 multiplied by cosine because I'm looking for the F1x. The cosine is 28, or the angle is 28, and the answer is 38.48. So let me write it on the sketch itself. Now, what about Fy? We just correct the cosine or convert the cosine into sine. So the same values, but instead of cosine, we're going to use the sine because we are looking for the F1y. And the answer is 20.65. Now, again here, for the F2, this angle is horizontal or X type. So the F cosine should be for the Fx, should be applied for the Fx. So let me use the calculator again to find the values for F2x and F2y. Remember, for F2x, we multiply the F2 with the cosine. So 26.5 multiplied by the cosine of the angle, and the angle here is 56. No need to include the sign at all here. We're going to deal only with the magnitude. Later, we're going to add the signs. 14.81. And what about the F2y? We will replace now this cosine with sine. So this is 21.96. Now here, the graph will help me to find the Fnet along the horizontal and along the vertical. So let's find the Fnet for the horizontal. We're going to add everything horizontally. Now the Fnet horizontally, Fnet x is equal. Here in this step, we're going to include the direction. We start with the plus, so 38.84. And for the second one, we're going to add the minus because it's pointed to the left. So this force is pointed to the left. This is why here I'm going to add the minus 14.81. Remember, this method, it's super useful if you want to save time and if the structure of question does not require from you to use the matrix notation. Now, in this sketch, I didn't add the signs at all because it's obvious that this is right, this is left, etc. Whenever I want to find the Fnet x, I just add the numbers with the corresponding signs, depends on the direction. So right positive, left is negative. Now let's find the net along the x-axis, 38.84 minus 14.8. So the answer is 24.04. Now we have the Fnet x. Now it's time to find the Fnet y. Plus 20.65. And the other force is 21.96. And one downward, which is minus 31 because down is minus. Now we will complete that the Fnet y is equal. Let's add everything together using the calculator. Minus 31. And the answer is 11.61. Let me double check. 20.65, 21.96 minus 31. So the answer is 11.61. Now we have everything to start calculating the magnitude of the Fnet because we have the x component as well as the y component. So let me use them to find the Fnet. Now let's write here the magnitude of the Fnet. the f net is equal the f net x squared plus the f net y squared, which is equal to 24.04 squared plus 11.61 squared. So the answer is 26.69. Now, after we've done it from the f net, let's find the direction or the magnitude of the f net. Let's start with finding the direction. The direction is theta equal tangent inverse fy over fx, which is equal to tangent inverse fy, which is given by the 11.61 over 24.04, and the value of the angle 25.77 degree. This is the direction. Now the last question for today, again here we need to find the f net. We have different ways to solve this question. We can use or follow the matrix notation, or if we are asking or we want to save some time, we can make the components or make a sketch for the components, and we add the components horizontally together and the components vertically together. In this way, we will find the f net along the x-axis, the f net along the y-axis. Now here in this question, I would like to use the matrix notation instead of that. So let's start with the matrix notation. Let me start with F1. Now, as you can see here, the F1 is completely and perfectly aligned with the x-axis. No need to decompose it. However, here, the vertical component of the F1 is going to be 0. So the matrix notation of F1, it will be -9 because it's pointing to the left and no vertical component. Now, let's start with F2. Let's decompose F2. Now, the type of the angle here is theta with the y, which means the cosine should be the f cosine should be belong to the f2y. Now, since this force is in the third quadrant, this means everything gonna be negative here. So this is the f2, 6, cosine the angle, which is 60. And here we have minus f2 sine 60. Now, the answers are minus, for the first one, is 3 radical 3 Newton. For the second one, it's just minus 3 Newton. Now the matrix notation for F2 is given by minus 3 radical 3 and minus 3 Newton. Now what about the F3? Now as we can see here, the F3 is the type of the angle here is with respect to the y again. So the cosine, F cosine should be applied for the f of y. So f3x and f3y. Now for the f3x, it's gonna be sine, and here we can apply the cosine. What about the signs or the directions? Now f3 is to the right for the f3x and downward for the f3y, which means the minus only can be found in the f3y. So let's add minus. The f3 is 4. We need to apply the cosine here because the type of the angle is the y type, cosine of 40 degree, and here we have 4 sine of 40 degree. Now the matrix notation of F3 is given by 2.57 minus 3.06 Newton. We still need to decompose F4. Now for F4, we have two components, F4x and F4y. Now, since the F4 is in the first quadrant, which means both components are positive, and since the measured angle is theta with respect to the x, so the cosine or the F cosine should be applied for the x component. Here we're gonna write F4 times cosine. F4 is 4 multiplied by cosine, that's 60. And here 4 sine 60. And the answers are 2 Newton here and 2 radical 3 Newton there. So for F4 we have 2 radical 3 Newton. Let me collect all the matrix notation or matrices for F2, F3 in one line together. So minus a 3 radical 3 minus a 3. And for F3 is equal 2.57 minus a 3.06. And finally for F4, it's equal to 2 radical 3. Now we need to find the net, which means we're going to combine everything together. Equal to, remember that all the entries in the first row should be combined together with the corresponding signs, as well as for the second row, we combine all the entries together. So let's start with the first row. We have minus 9 plus minus a 3 radical 3 plus 2.57 plus 2. Double check. Everything is correct. So let me press now equal. Minus 9.62. Now for the second one, we have 0 plus minus a 3 plus minus 3.06 plus 2 radical 3 minus 2.59. So the F net now in the matrix notation is given by minus 9.62 minus 2.59 Newton. We still need to find the magnitude as well as the direction. So let's start with the magnitude. So the F net is equal square root F of x squared plus F of y squared. Remember that the first entry here represent the fx, the second entry represent the fy. So the F net is equal minus 9.62 squared plus minus 2.59 squared. We still need to find the direction of this F net. Now the Fy is given by this component, so minus 2.559, and the Fx is given by this component, so it's going to be minus 9.62, 15.068. That's it for today. Thank you for watching and see you in new videos soon.